good evening, good afternoon, good morning, from whichever the part of the world you are in. Welcome to our 57th webinar. Today we have with us Mr. Suresh Yeddu. Mr. Suresh Yeddu is a highly experienced tunneling professional and vice president at RV Associates with more than 2 decades of expertise in tunnel design, construction supervision, and underground infrastructure projects. He is an alumni of IIT Delhi, specializing in rock engineering and underground structures. He has extensive experience in NATM, TBM, and underground station works. His international projects exposure spans the UK, UAE, Oman, and India, contributing to complex metro and transportation tunneling projects worldwide. We are pleased to have you on our webinar platform, Mr. Edu. The stage is all yours. You may now start the webinar.
Yes, and yes, thank you very much. And it is a very privileged and very great honor to be part of it. See, let me speak very frankly. My words, my lecture, perhaps very good for young professionals, especially who are in India. Perhaps seniors, it's a kind of a knowledge sharing only, especially in perspective of young professionals who are here. I would say they were very happy and very proud to be here as well. The reason being, when we started those days, we did not have many tools and opportunities to work massive tunnel projects. That's the reason. So we had to go to abroad. But nowadays, India is the place where this is the hub of the world for the tunneling. So this is the reason I would say you all are lucky, myself also lucky. And also, what I would like to tell you, dear friends, especially me, a country like India is fully committed on infrastructures, especially all is ours, completely underground structures, are completely wherever you go. The reason being, the land is so expansive, so many other reasons as well. So this is I would like to put forward my message to all young professionals. You are glad to be and part of being a Indian young professionals as well. And let me start with the actual business. See, today I would like to emphasize two elements only. I do not want into more into design, especially TBM or whatever NATM or stations. I just like to give a guidelines. The first thing, being a tunnel engineer, refinement of tunnels is a priority and the first most thing I'm supposed to do. We may say, why would I do being a tunnel engineer? This is not at all. Being a civil engineer, whatever engineer, this is our responsibility to define the alignment. Though it is predominantly related to geology, but still we have to be some parts where our expertise required as well. So coming slides, I will show being a tunnel designer, what is your role? How would the role be the next level of the engineering? Please, next slide. As I said, two entities you can see. One is refinement, the other one is the practical ground models. One would say, why, how the refinement plays a big role and massively. That is what I would like to talk about. The reason being, once you refine, the refinement is the tunnels is literally related to the tunnel project cost as well as construction, as well as the work manpowers. The all about everything is a business end of the day, dear friends, we agree or not. But our job is what we can do, we can't. Every contribution is valid. So being a young professionals, particularly beginning of ages, please concentrate on refinement and tunnels as well. And the second, move on to next entity, practical ground models. Of course, you are very equipped and very talented people, enabled to produce hypothetical and theoretical and very good knowledge. Most of them, whether they come from good reputed university or very much vulnerable university, doesn't matter. End of the day, we could produce being a civil engineer. So for this reason, I would a little bit segregate how it plays a big role. So first, refinement of tunnels means what we do first. Especially for NAT tunnels, the geological hazards they plays a big role. how extend the geological hazards places and what to do, how to do is all I will emphasize. Secondly, especially for the TBM tunnels in urban areas and where the density is more, the value is very important. Those are areas like high-rise buildings and especially petrol stations and bore wells and exiting infrastructures like flyovers, river crossings, railways lines. These all are the main hurdles. These are the challengings when we being a tunnel designer to refine the tunnel alignments. So I will move on to the next slide. Dear friends, this is completely never ever think this is not our cup of tea being a civil engineer, not at all. My experience says that once you're good at primary things like how the geological hazards, what are the geological hazards? Firstly, please work out. Let us say I've given you a few examples like a falls, pools, bedding planes, truss. These all are part of hazards. So these are the first geological hazards we are able to identify as well. We cannot simply say one cannot simply say this is entirely geologist and this I'm not interested, not at all. This is also part of our job. Being a civil engineer, we have to identify those things. Afterwards, let me go to the second chapter. Why? Because the tunnel alignment always interface with the geological hazards. Let me give it another three examples. That is the one case as I showed you. If you see our fault axis, which is a upward direction, and our tunnel axis in a different direction. If it is at all parallel, not at all safe. The reason being in the IS codes also, if you take in European codes also, it creates massive surprises. The work construct happens, the cavity takes place. Such cases primarily you have to identify, accordingly you have to find the alignment. And second example I given pools as well, like pools, falls, truss, we are able to identify and how they interface with our alignment. How far we can, in some cases we cannot avoid it, but at least how far we can maintain to reduce the massive impacts and massive hampers in the construction of tunneling. That is what's supposed to do. Other one is depend strike, and which is favorable and which is unfavorable. Also, we're supposed to know. Let us say if the strike is parallel to tunnel access, is it really safe? Is it not safe? We are unable to make it happen. When we go to site, this is a big role. At site level also, we can change parallel to strike, so it is a massive issue for the construction. That is what supposed to do. Can you go to the next one, please? Yes. The question is next one, how to refine the tunnel alignment when there are so many geohazards. This is completely in-house, perhaps we have to do. There are two things we can do in-house, like one can easily download GIS district resource maps from GIS website, or we can buy it on. Identify all the geological hazards where we done geological left-hand side. Then you can use the QGIS software and refine it off and make a identify all the major geological hazards like landslides and faults, shear zones, and all other most of the geological hazards we can identify at this level. This is in-house, completely we can do at the in-house. Once it is done, we come to know next one is geological mapping. This is a very, very key and bone to the work. It is the most important thing for the tunneling as well. The reason being, when we believe something, we worked out something, assuming something, but they actually happen, what exactly happening at at the site level. The experts they go and identify all the things, the geological map, through geological mapping, what we talked about. They give good GCGS coordinates and everything accordingly we come to. I did not show this. Is what happens is here from geological mapping, especially we will get the longitudinal profile and Chinese. At particular challenges, wherever you encounter the geological hazards are replicating, they are marking. So that this is a precautious for the actual when they're going to start the work tunneling. Let us say there is Chinese, some 100 Chinese, we encounter massive thrust zone. So this is a pre-indication. Then immediately at site people, they have to deploy the very expertise engineer, tell the site team we are encountering very soon thrust zone, very careful of it. That is primarily one engineer is supposed to identify those things. For the next one, please. See, that is the part of NATM. Let's come to the TBM cases. As I earlier said, most of the TBM passing through infrastructure process like flyovers, already rivers, and bridges. These are all things. For example, I encountered somewhere in a metro project, literally our tunnels, both tunnels underneath the bridge, a flyover, which is a very aged bridge, and this is a configuration what we encountered. Then client said, please refine the alignment. Then what I do, I simply say, I have a three options. One is the analytical, and the other one is a closed form solution. The final was a numerical one. This is the only alternate we can do. We try to use any one of them, especially numerical analysis. Perhaps PM plays a big role prevails. Why? Because if there are two tunnels, we cannot generate CFS equations to get the good results. That's the reason. So in these cases, there's no doubt numerical FEM analysis prevails. So such cases also, now I'm moving to geologist to engineering, being an engineer. We suppose, for example, we cannot expect a geologist supposed to do this kind of refinement. So being an engineer, we supposed to do these things. Other one is, as I said earlier, not only tunnels, but the cut and cover is also part of us. Cut and cover and underground station, these all are part of us because we all are underground structures. One, we cannot stick to only, I know, tunneling, but of course, cut and cover also part of us. As we know, cut and cover means cuts definitely depend upon the depth criteria or diameter of the tunnel. Let us say when open cuts, especially in mountain areas, what I believe that try to avoid it off. The reason being there is a flash flood, so many reasons. So we cannot suggest open cuts. Instead, you may recommend cut and cover. This is what my experience says. So when you cut massive cuts comes also, try to reduce it off. Let us say cut is required 40-meter deep. Can we recommend not at all? Because it's so complicated. Because if it's unfortunately, unknowingly, knowingly, if we encounter sound rock, let us say uses more than concrete, then it is a massive problem. We cannot do at all. Such cases also primarily we are in a deeper stage also. We have to estimate what is possible, what is not possible. That is also part of us. This is the way we have to refine the cut and cover type of tunnels and open cuts as well. This is, my friends, I would like to say, this is another case study for one of the metros. Let us say all of you know who especially worked in metros. Once elevated corridor finished off, then our underground starts with open cut or cut and cover. Very busy places where the density of the people more, buildings are more, the roads are very important. Such cases we cannot put very longer open cuts. The reason being, once if somebody recommending longer open cuts, we try to tell the client that it is not feasible. Being because of this open cut, we have to arrest everything. There is no people movement at all. Firstly, because it's open to the sky. And second, we have to divert the traffic. These are all issues one has to primarily consider when they are working for the tunnel alignments or loose alignment. Dear friends, we should consider open cuts and cut and covers and underground spaces, especially temporary structures. This is also part of us. So we cannot avoid these kind of things. Especially cut and covers literally possible. Why? Because we cut it off, then we fill it off. Still, it depends upon the deeper cuts. We cannot, like a double track cut and covers. Let us say that is massively required. Such cases also one has to very carefully examine. Accordingly, we have to refine the alignment. Thank you. Other one, please. I think so far I covered how to refine the alignment. I hope it made some importance for that. Now I would like to go on more into design, but structural precast segments, the steel segments, those things I do not want to discuss at the moment. The basic things, how it works out, this is what I would like to emphasize at the moment. What I would like to say, dear friends, NATM is design as you go. There's nobody guarantee, nobody say, yes, this is my design is correct. The reason being, let us say, the reason being I'm saying, usually use two ground models. One is a more cool loop and is a Oak and Brown for FEM analysis when you do it. Based on that, we give the some support system. We design models like empirically we estimate, analytically we estimate, FEM we estimate. Yes, CCM also we can estimate. So we estimating something. So that has to be justified actually by phase log zone. It means practically what the phase log, geological phase map is, that is actually correct. So we have to change our design models. Practically, we have to agree that how good at we are hypothetically, that plays a little bit role, but practically like instrument and monitoring also plays a big role. These are the things we cannot avoid. We should completely rely on that. For instance, I work some part of the world. Whatever you design, that has to be reliability because they made it a legitimate. They made it a law. Means we shouldn't. When we design something, there has to be some reliability. Although applicability is different, but reliability. If there is no reliability, then is a massive issue, and cannot be a good designer. Then it can be law as well. Some Middle East, they may be some other very strict rules as well. So what I would like to say that in this, what I want to make a point out of it is you design whatever the hypothesis, but that has to be synchronized with your practical approach. Eventually, you take a call such as like instrumentation monitoring method. Let us say you design something. End of the day, the instrument monitoring during construction, post construction tells us what exactly the structure behaves. So that is the what reliability we supposed to able to make a platform of it. This is what about an ATM. Let us say, for instance, give me one case study. Let us say, I think regarding this, we had a good word with friend of mine, Mr. Rishabh Gupta, who is from Rights also. He is a very well-known tunnel designer. So we had a good discussion about these ones. Let us say, especially tunnel, beginning of the tunnel portal, there are two things coming. One is we have to specially design for the tunnel portal class, certain X distance something, either side of the portal. Let us say for namesake, I'm given 5 or 6. Yes, this is well and good at estimated one, but practically when you go to the site, it may changes. Are we still adapting the what we designed? I don't think so. Safety is a paramount priority, but ground reality says different means yes, that can be that can be avoided. This is what my experience says. What I say, this is my experience says. I'm not anything at all making it a mandatory. This is my experience says. This is what I would like to talk about. Especially young engineers, when they go for this, these are the things they have to notice how the practicality into actual design and make it a reliability. I'm again emphasizing reliability. Once you give a confidence, reliability, then only the reliability factor increase. Then only the investors will also increase investing more into infrastructures. If there is no reliability, we cannot expect more investors as well. For instance, in a design point of view, portal slopes, these we generally generate based on the normal, whatever the guidelines, the Indian guidelines, the providing this slope, we can say 1:4 and 1:1 based on the strat and all. But in practicality, what you have to think about, what is above is coming. For instance, in this case, the road is coming above the tunnel. Can we go for the same one? Because there's so much success is coming. So these all things practically one has to go and decide these kind of slopes and everything. The sloping, how much air is coming, how much width they have to maintain. These all pretty much practicality. This is what I would say. Please go to the next one. This is the more sensitive slide. This is a what we talk a little bit very careful. The reason being, this is a purely TBM and underground stations. Dear friends, I worked both. One is in TBM, one is a precast segment. Usually we may see like in India. Other one steel segments, like a steel segment. When I was in London, that time I worked for underground tunnels around about 2 years. We used to inspect those tunnels and we then be reassessment, we done the designs. What it means it gives good experience, there's no doubt at all. The reason being, they did not use TBM, they might have used the concept NATM board. And then they used instrumentation monitoring. So such cases it works out. But when you come to the precast segments, generally instrumentation monitoring won't work for we cannot measure the how much deformation coming actually in the precast segment. The only option we can see, it is again related to other things like phase pressure and volume loss and everything segments. In such cases, the only thing instrumentation monitoring also plays a big role to large extent above the tunnel only. Like if the tunnel is not able to take any loads, then definitely the surface instruments it uses that can be predicted by MPBX and other instruments as well. Still, if there's only one chance left out with the TBM that once you've done the segment lining, then they do wriggle survey, means alignment of the segments and how the alignment are. But you may not give the actual deformation of the tunnel segment. Let us say I'm designing a segment 25 mm deformations like LBS 260, whatever so. So I don't want him to design part. That's what I'm saying. And also being a designer, we have to take a call. Like let us say, when for most of the C5 plays a role, means mostly we use the more Coulomb criteria. Hook and Brown means general RM, if it is a rock, then we use. There is soil hardening also. Here I would like to emphasize a bit more. Let us say for a design model, there are predominantly three models. One is Dudek, especially I used for steel segments and I used flax on when I was with Atkins. But the second one is Mood. Yes, is a wonderful design model. He's a very good scientist. And he produced for the very good equations to estimate the lining stiffnesses and everything, especially for the precast concrete segments. Can I use the steel segments? Means to large extent, I would say no. Why? Because when I was there, they literally told me that Dudek is the best way, and we experimented with. What we done was we used flax, and to compatibility point, we used flaxes as well. So that point of view, we believe that better to stick with the Dudek. And afterwards, John Curtis also, we can use it for the both rock as well as soil also. There's no doubt about one. What I would like to emphasize here, mainly thing is that, see, we know, let us say I'm designed with a more Coulomb criteria for the precast segment design. Then the inducing settlement above the ground at the surface level are causing something very excessively or not with any limitations or sometimes with limitations. Such cases, what we do with excess means, then in the same time, then what I done, then I used some soil hardening clay method where I increase the Young's modulus. Usually it is defined Young's modulus 1E. Because of soil hardening model when I use, I increase 3E. Then it worked out, honestly speaking. My colleague will draw. Can you draw that configuration of the tunnel? Like the same like like whatever the underground station I done, same like the tunnel also. Let us draw. It's not coming. That's fine. That's fine. So what I want is, let us say go to the right hand side, the corner pictures, which is similar to tunnels only, but it is especially for the, let's presume that these are two tunnels. So when I increase the 3E concept using some more cool instead of more cooling, then my settlements literally reduce. This is practically I have seen, which means that why not? We can do that. We can substantiate that my statement is a practical applicable. So I can do it according to make it legitimate. The reason also we can do, because honestly speaking, once we do segment precast erection time, we do a lot of primary grouting and the secondary grouting, which means that influence of the water of the tunnel we are concretizing, solicitizing, means that yes, there is a young small may increase. So first I started with 2E and then 3E, like 5E. So my belief that 3 is okay. Then I changed it. So this is what practicality one should develop. That's the reason this is very sensitive slide. This is what reason I said so. And let's move on to the underground station part. So the same thing, when you excavate underground station, generally for settlement analysis, somebody uses some very good softwares like Velap and all. Let us say a simple thing when you excavate when I excavate, give me one example case study where I done. We excavate entry and exit at nearing to All India Radio building. We estimated using Berlin, CASPA, and Pergos. We estimated some settlements because of using these equations. But when we gone to the site, it is entirely different. We encounter a little bit of water as well. So what we'll do? Can these equation works? Not at all. Our settlement is entirely different. So such cases, being an engineer, we have to take engineering form. Then what would be the next? Whether you have to put a dummy struct, or these all practically have to make a judgment, not because of the what hypothetical models are giving propositions. This is what I would like to tell. Dear friend, this is a very important slide. I wanted to move on to next one. Next, this is being a tunnel designer, especially for NATM tunnels, phase stability plays a big role. Especially here, I would like to emphasize very tricky way, but please try to understand that. See, whenever there is a C5 soils, normally we believe that there is a wedge model and we develop based on the one engineer Brooms and Banmore, the scientist, he given that equation. Based on that, we estimate something, some that much phase stability, if this much length may require, this much length may get disturbed, or this much settlement may induce. There's the wedge analysis. This is for C5 soils. And next, move on to the next slide, please. The same thing, when I done it for phase stability for the cohesive soils, I used the Meyer method. This is practically one case study for metro projects also we done. Eventually, we get some, let us say, some 52 mm something. I got the settlement. Little bit higher side. Generally, we restricted to vertical settlement according any code, perhaps 25 mm. For underground stations, horizontal settlements, we can allow up to 40 because serious saying. Again, I am saying what serious saying that is related to UK perspective, but here you can prove it off also. How you prove it off means the best way to judge is the instrument monitoring also. So what I would like to point out here means the phase stability for NATM tunnels where the cohesion and cohesive soil, cohesive soil is coming. Yes, it works out Meyer and not. But what about when the rock strata comes? Because in NATM rock strata may especially coming predominantly. Then such cases, can I go for these equations? I would say rather no. Exclusively for the weather rock strata conditions. You may presume this one, but still we have to justify our presumptions, theoretical ones, with the help of the instrumentation monitoring only. Means practically one can justify using these the techniques only. This is what I would like to tell about this slide. Next, the next one again, in case of NATM tunnels, the phase stability. In case of the TBM tunnel, the phase pressure also. Here I would like to give it with a very good case study also. Let us say I'm assume wherever there is the C5 soil, I'm using Terzaghi silo theory. I have estimated some phase pressure. Literally, it doesn't literally when I use this much phase pressure, we encounter massive settlements. God said what happened was we really rethink of it and we changed the model. We changed the other model and we used Coveri and Agnesto. Then we got the very good phase pressure results and the inducing settlements reduced drastically, which means this is everything is practical. You just if it doesn't work A, you have to move on to B. We're never able to stick to A only. Then how could I say that which is correct? That is the only option, tunnel deformation and instrument model results only. I'm saying, but in case of the tunnel deformation, lining deformation, I may not guarantee, but at least the surface settlements and all we can justify using the instrumentation and monitoring results. What I would like to say. Yes, finally, here I would like to say when we are sticking with the TBM tunnel, there are four parameters one has to be very carefully designed in a practical point of view also. Let us say I'm designing TBM torque with some 45,000 kilonewtons, and we have to estimate also theoretically. The torque is literally depend upon the phase pressure. Phase pressure will interlink with the volume loss. The volume loss, because of volume loss, the settlement inducing. So these all are synchronous, these are interlinked. So one has to estimate very carefully. For example, for a single tunnel, yes, I can use closed form solution and I can estimate the how much settlement, how much volume loss and all we can estimate. But if you say very double tunnel or staggered tunnel, one should go with the FEML only because there's no option at all. Because the closed form solutions, when you interlink with the multiple tunnels, you may not get good results. This is what I would like to tell about this slide. Somewhere FEM prevails, sometimes real-time monitoring also prevails. So we did eventually what we design means that has to be mostly linking with real-time monitoring. This is how do we rely how this is the way how we have to give reliability of our designs only. This is what I feel it of. And thank you very much. I hope I made it somewhat very clear to most of the massive and major design parameters, especially in case of NATM and in case of TBM. Thank you very much. Yeah. Yeah.
Hello.
Hello, please.
Yeah. Thank you, Suresh. Now, let's move to the Q&A session. Please type question into message box or maybe raise hand. Okay. Emma Shah has raised a hand. Can you please switch on your mic and ask the question? Hello.
Yes, please.
Uh, Emma please could you please switch on your mic and ask the question? Yeah.
Audible now?
Yeah.
Yes, please,
There
please.
is a question. In case of metros, what I understand, the volume loss generally we take around 1%, and in some cases where buildings are over the tunnel, it is 5% also. But I want to understand a case, for example, if we are using a TBM in Himalayan terrain where the overburden is very high. So in that case, how we govern this volume loss? At what volume loss should we operate? And what will be the criteria to decide this volume loss in that case?
No, first volume losses. This is a very good question. This is a very repeated questions. I've been there, but let me put this way. Whatever back volume is calculations also, we can do it. How we do it means when you, but before you estimate something, you can consider 0.3 or 0.5, whatever. So any attempt you will go for the 2%. But especially for TBM tunnel, when you assume something means then let the tunnel mining goes on. Then when you go to the site, we can take the how much phase pressure is they were having. Then back calculation, you know the phase pressure and you know the settlement already. Then back calculation, you will get the actual how much volume loss per ton. Actually, that slide is I'm having, but I did not show that. Show this slide, please. There are two things. One is the how to estimate the volume loss back the volume loss. Other one is thrust also. With the same thing, how much that is I'm designing thrust force also 5,000 kilonewtons. But actually, how much I'm using means you when you go to the site, you will come to know also because you take the value and you can estimate as well based on the how much actually they are applying phase pressure. So that's what I'm saying. You presume something, then you go to one has to go to the practical, go to the site, go to the where the mining takes place, take the values like phase pressure values and re-estimate. Why? Because the volume of the tunnel we know already, and especially volume losses. What happens? Volume of tunnel you know already. Let us say 6.2 whatever 36 to something meters per come. Then the trough area you already know. Trough you know already because that how you know me the very shallow depths. But in case of higher overburdens, again this is a call of your engineering judgment. One cannot because I cannot do 200 meters Mbpx hole for that. That is rightly asked the question. So this it depends upon the your engineering judgment only. In a shallow depth, we can put Mbpx and we can get the trough, how much trough is there. We can estimate the back calculate the volume loss. But very deeper depths, definitely. That is a pure engineering judgment. This is what I say. And
I hope,
also,
yeah, sorry.
and
Go ahead, sir.
also, I'll also say when there is a massive overburden, honestly speaking, the service settlements and all not at all for us massive criteria because of the tunnel influence up to 2D, 3D only main the load is coming. So about that, honestly speaking, may not be much influence to large extent. This is what my experience says.
Okay. Thank you for the answer, sir. The next one is Kalon. Could you please switch on your mic and ask?
Hello, sir. Am I audible?
Yes, please, sir.
Yeah. So actually, in the ground models and design models, you have, I think, like correlated molecular model with Dudek model, and then hook down with Moal wood model. So, does it mean that like we cannot use hook down model and Dudek model both in same time simultaneously? Does it mean so?
So what is sorry what is saying? Sorry for okay. What is the question? Can you make it elaborate the question, please? Sorry, apologies about that. I couldn't able to.
this
Yeah,
this
please,
one.
please. Yeah, this is a very sensitive slide actually. Yes, please ask the question, please.
So like actually you have correlated hook down with mole wood and then more column with dudek. So like is there any reason ki like can I use hook down with dudek and is there any specific reason that you have correlated hook down and mole wood and more column and dudek?
Sir, what
Is there any
happens
reason?
is the client, let us say there is a compatibility issue coming. Let us say when you design, let us say C5 soil means generally immediately we go for the more good estimate. For Dudek case, yes, normally where there is a clay, like Dudek developed most of the cases in London area. So they used Dudek. So for whenever rock is coming, again we have to use more wood. So every time whenever the client asks what is the best, means compatibility only. This is what I would like. Like I estimated using today, I estimated using wood and cortisol. Some people are very kind to me, so they ask me at least make it 2 or make it 3, then compare with our FEM analysis. So this is entire engineering call. That is what I'm saying.
Okay.
So
Okay. So got it.
yes.
Good. And so like sir, what is I&M method? I&M method, I think you mentioned 2-3 slides before.
Sir, that is
I think
instrumentation monitoring, sir.
okay, sir. Uh, yeah.
Because the reason being, for TBM tunnel deformation of lining, there is no instrumentation. Generally, we can't do it at all. And for any TBS, there is a practically possible, but TBM not at all. Because this is what the design part we just based on FEM analysis only. We mostly figure out, and I don't know who would also we can estimate also little bit.
Okay.
But STAT kindly do not use STAT because we got a very horrible results for the when we used for STAT.
Okay. Yeah. And so like at the last, I think you showed one graph which had the heading of TBM torque, phase pressure, volume loss, this thing. What this graph shows actually, can you please explain a bit?
No, I simply what I would like to tell you here. Whenever there is a 2 TBM configuration, let us say 1 TBM configuration means we generally use most of the volume losses, phase pressure, everything we can estimate based on equations. But when there is a two tunnel configuration, we may not estimate using closed form solution, means multi or staggered tunnels. In such cases, what we generally FEM prevails. Then the question is how the TBM torque you will actually put into your FEM analysis. I would say we cannot put the TBM torque into FEM reveals, but back calculations we can do. What I would say, let us say based on your FEM analysis, we estimated some deformation. Again, I'm saying, so let us I'm designing a tunnel using a TBM, 45,000 torque. But in practical, how much is coming, we know. Why? Because how much phase pressure, bar, they know that. Accordingly, we can calculate back calculate the torque. Means which is everything is interlinking, which is inducing settlement. This is what I would like to say.
Okay, sir, got it, sir.
Thank
you, sir. Thank you.
Thank you, sir.
Any other question? I believe no one is raising. Yeah. MS, sir, please switch on your mic.
Yes, sorry, actually I was traveling and my network got
Please, sir.
the previous question I had asked. Uh, uh,
Your voice is not.
Based upon what
Hello, MS, sir, your voice is not good. It's breaking a little bit. Hello. Maybe you can put your question in chat box. Hello. Am I audible?
Yes, please.
I think his network got disconnected. Maybe we will share the question with you via mail.
Always,
And
always welcome. Please share it off. Very soon I'm going to give another seminar also. Please.
yeah, I think there is no more question.
Yeah, thank
Yeah, thank you, Suresh, for delivering such an insightful webinar and for the answers and providing detailed insights.
Yes, and let me conclude this way, dear friends. This is very much honored to be here also. Why? Because some questions are very good questions. Like, see, why I'm a little bit like to say that these questions we used to ask 20 years ago. But now the same question asking this time also means how much deep you're studying. This is what I would like to say. It's not about how many years of experience, but how much you're a very young man, or very young professionals. But they ask me very good questions that will where there is a lot of work, but how do you estimate value? These are international questions what I have faced also. So literally I'm very pleased and thank you so much for your time and thank you very much. Have a good evening as well. Thank you.
Yeah, thank you all of you for attending this insightful lecture. If you are not yet a member and would like to join, please reach out to us via LinkedIn or Gmail or website for the details. Once again, thank you, Suresh, for sharing your expertise, and thank you for all attending. Wishing you a productive week ahead. Stay safe and happy.